Hi, my name is David, and this video is to show how you might use this Google Colab notebook I've created for the purpose of modifying images. The kind of change that this software makes to an image can be seen in the examples here. So it applies a compression to portions of an image. So in particular, the software code attempts to create a gradient of compression, starting in a focus area where the image is high fidelity, in this case the crocodile's eye, and then moving away from there, it applies a gradient of compression, as I mentioned. So here's an example of the modes that are available. So there's a square mode where, starting from your focus area, the image will compress outward in all directions. Alternatively, there's a horizontal gradient where, starting from your focus area, the horizontal band that it's in will be high fidelity, and then compression will move outwards. And alternatively, there's the vertical option where, starting from the portion you identify as the focus area, in this case a vertical strip of this mountain range, the compression will move outwards away from that. And lastly, there's a multi-focus area settings. Oh, that's not the last thing. There's a cross type as well. So here you can see the focus is on this man's face. And in addition to the vertical band being high fidelity, there's the horizontal band as well. So that's the cross type. And lastly, there's the multi-focus area. So here you can see his face, and the text is not compressed, but the rest of the image is. So I just wanted to show how you could use this. Basically, you're going to open this program in Google Colab, and then you can just drag and drop a file into this file area, folder area on the Google computer. So I already downloaded an image of Usain Bolt, so that's over here. Once you've done that, you can just type in that image name right over there, and from there you're going to set your focus area and your other settings. So to do that, I'll just open the image in Microsoft Paint or some other simple image viewing software that would allow you to see the pixel count of where your cursor is. So I'll just show that in a second here. So here's an image of Usain Bolt. That's the one we're going to open. So I'll set the focus as being on his body. So I'll start over here, and at the bottom of the Microsoft window, you can see that this is at row 74, column 892. So I'll just put here focus area 74, 892. And then I'll grab the bottom right cell. I'll just take the bottom of his torso over here, 201, 938. And so that's the focus area. So as you can see, the format is that you have the top left cell coordinates, row 1, column 1, and then the bottom right cell of your focus area, row 2, column 2. So then what you select is your rank. And what this software does is it uses the singular value decomposition method for a matrix approximation. And so you could do more research on that to see what the rank is about. But basically, the higher your upper bound, the greater the fidelity will be as the gradient of compression approaches the focus area. So I have a recommended value here of 15 that will give a very high fidelity image. The gradient will be smooth near the image, so we could just try it out with 9 so it computes a little bit faster. And a rank step, I recommend it as 1. Basically that just means it's going in a non-linear fashion, and we can make the gradient square just to see what happens. So now that I've got that in, I can just hit run, and alright, there's a bug. What is it? Invalid syntax. Well, I seem to have deleted the comma. I wasn't expecting a bug, and so there that is. It should work fine now. To make sure the format is followed very strictly, you need to have what's called a tuple, which is bracketed entry on the left side of the comma, and then another one on the right side, and both of those within round brackets, and then both of those within square brackets. Alright, so that has finished now. And here we see that there's Usain Bolt, and it's compressing. So I could actually download this image, and then we can view it in higher larger size just to really get a sense of what's going on there. So I just downloaded that, and I'll open it in the window there. Open with Paint. And it looks like I downloaded the wrong one. I downloaded both instead of gradient output. So this image here will be gradient output, as you can see on that folder there. So if you just save that and open it, you can see that image here. So it's always in grayscale. You could see when we have it larger like this that there is compression around his torso except for the area we specified. That's high fidelity according to the original image. And then as it progresses further away, the compression is greater and greater. So it looks like almost like he's being chased by some ghosts there. So another thing we could do is create a horizontal band or a vertical band, as I mentioned earlier. So to do that, you would change the gradient type over here. So number 2 makes a horizontal band. We can just run that and see what that looks like. I should run it more quickly. So what this is going to look like is that there's going to be a horizontal band that's high fidelity around his torso, right? So we can see these guys' legs at the top over here because that's in line with his torso horizontally. That's all high fidelity. And alternatively, we can do a vertical band. So that will be gradient type 3. And that will go from there. So another thing, another variable for control is the variable determining how much weight each band gets. So here you can see it remains high fidelity for some time and then it decomposes. So what you can do is have that gradient go more, so to speak, more quickly or more slowly. You could give more weight to the high fidelity or to the low fidelity. And how you do that is with bandwidth. So with bandwidth corresponds to the weight given to each gradient. So in this case, positive numbers will give more weight to the higher fidelity. So for example, if I do negative, I'll just do -3. What you'll expect, as I see here, what you'll expect is that the more decomposed gradients, the more compressed, will have much greater weight, and so that image will be much more decomposed. So let's take a look at that. And you can see here it's very, very decomposed. It's all you can, to see the other runners, you can only see that these bands are darker. So instead I'll make that number closer to 0 but still negative. For example, -0.5. What we can expect here is that the gradient will still have, it'll be worse, it'll be less, have less fidelity than what we were looking at earlier. So much less fidelity than some of the original samples we looked at, but at the same time, it's still better than that last one we were looking at. So that's how you can actually modify the weight, the width of the given bands. And if you make it this equal to 0, each band of the compressed region will have a equal weight. And so how this is working is essentially it's taking it's compressing the image many different times to different degrees, and then it's just overlaying these different images on top of each other, progressing towards the middle or the specified point, at which point it's just the original. So this one, this is a pretty interesting number, kind of just to see these guys dissolving as they're running towards him. So kind of like a video game if you had the winner finish the race and then the rest of them just dissolve, something like that. So just for fun, I'll change that one more time, and then I'll end this video. So that was 0. So what I can do there is just make it -0.1 or some such. Actually, going to be +0.1, or I'll just make it 2. So going into the positive number region will make the picture generally more high fidelity. Right. So that's pretty cool. My motivation for this project was largely just curiosity and wanting to get this to work. And it was a great practice with proper indexing of different data types. So what we've been scrolling past this whole time is the code itself. Um, so I'll probably make a video explaining how that works. But in any case, that's how this works and how you can use it. So thanks for watching. Take care.